Hello, Algebra 2 students. How are you doing? I hope you're well, and I hope you've been checking in so I can see your face on Google Meets, or send me an email. Make sure you're checking your answers on Big Ideas, uploading your assignments on the Google Classroom assignments. And please just let me know if you have any questions, need help with any of that stuff. I miss you guys, so I would love to talk to you. So we are on day 2 video of section 9.2. I'm kind of following along with the Big Ideas book. So if you have the book, or I know y'all have access to the online book, so you can look at that. Use that as a resource. Today we're going to focus on still angles in the unit circle, but we're going to look at how angles behave in the coordinate plane. I'm going to move on to the day 2 notes. If you could download these, you can write on them if you have a printer, or if you have a fancy computer system where you can write on your iPad or computer, whatever. Otherwise, you're welcome, of course, to just write on paper as much as you can. You've got this video, stop it, pause it. Do whatever you need to keep up with it. Replay it. Write down questions that you have of what I say. And let me know what they are, of course. So, again, back to the notes. So we're looking at angles that are in, it's called standard position. And so this is on a coordinate plane. Our initial side, our starting side of our angle, the ray is going to start at the origin, and then it's going to draw to the right. So right there is our initial, always the initial side. So we always start there on the x-axis for initial side. And then we're going to go counterclockwise to get to a positive, to show a positive angle degree. And remember how we number our quadrants? The top right quadrant is the first quadrant, and then we go counterclockwise to get to the second quadrant, and then we continue counterclockwise for the third, and then down to the fourth before we get back up to the first. So that's how we show positive degrees, angles, in a coordinate plane. If we wanted a negative degree angle, we would go clockwise direction. And so we draw in, you can see this little curve with an arrow to show which direction we went, because it's kind of tough sometimes to tell without the little arrow on the end to show which direction we went. And then we draw in our terminal ray, so wherever we end, that's called the terminal ray. We're going to practice drawing in some angles. We're going to start with our 240 degree angle. So we're going to start, when we draw our angle in, we're going to always start on the x-axis. So use a different color like I am, or try to draw a darker line on the x-axis. And then we're going to go 240 degrees counterclockwise, because that 240 is a positive angle. So that means I need to go 180 degrees, and then I need to go 60 degrees more. And we don't use a protractor to measure that angle. So because we're not using a protractor, we are going to mark off how many degrees the acute angles are. So just to show how much past 180 degrees I went. So I went 60 degrees past. And notice how on the that's supposed to be a nice curved red curve right there to show which direction I went. I put an arrow on the end of it because without that, it's hard to tell which direction you're going. So that represents my 240 degrees. You can go ahead and pause this video and try B yourself. Try drawing in a 500 degrees. So I'm going to start on the x-axis. So that's my initial ray. And 500 degrees. So I need to know, well, how much obviously I'm going to go all the way around the circle because that's more than 360 degrees. But how much more than 360 is it? So 500 minus 360 is 140 degrees. So I need to go all the way around the circle and then 140 degrees farther. So I'm going to start with my red curved line, and I'm going to show that I'm going all the way around the circle and then 140 degrees farther. So that's, those are supposed to be straight lines, just so you know. And this is 40 degrees less than 180. All right, next one is a negative 65 degrees. This way I'm going to go clockwise, starting on the x-axis, and then I'm going to go 65 degrees clockwise. So that's, approximately right there, and it's about 25 degrees short of the 90. So I'm going to draw in that curved angle to show that's my 65 degrees. Some people will write the 65 degrees in instead of the 25 degrees, but please make sure you put arrows on the ends. And obviously I'm not going to judge your curves, as long as you don't judge mine. Okay. So the next thing we're going to look at is called coterminal angles. Coterminal angles are angles, like pairs of angles, multiple angles, and they are sharing a terminal side. So the word is coinciding, meaning they have the same terminal side. Coterminal means they share the same terminal ray. So some of you I know are really good English people, and you probably know co, like all the root words. Anyway, it just means they share the same terminal side. And you can find them by the coterminal angles by adding or subtracting multiples of 360. I'm a more visual person, so I like to draw in my angles and see them that way. But I know some of you prefer, just to add and subtract 360. So we're starting with a positive angle and a negative angle that's coterminal with 395 degrees. I'm going to start by drawing in my 395 degree angle. I'm starting on the x-axis. 395 is positive, so I'm going to go counterclockwise. It's more than 360, so I'm going to go past 360, 35 degrees. So that's my 395. I want two angles that are coterminal. So my positive angle, coterminal, again, you always have to start on the x-axis. And so a positive coterminal angle has the same terminal ray, would be the 35 degree angle right there. A negative angle has to start on the x-axis, but it has to go clockwise. So that would be this direction. And so that's 365 minus the 35 degrees. And it's negative 325. And there's other ones you can continue going around and around in the circle to find multiple. So there's many different answers on these. These are, for me, just the first ones I come across. Negative 45 degrees, so I'm going to draw that one in to start with. That's going clockwise. That's my 45 degree angle, negative 45 degree angle. So if I want a positive angle, I would still start on the x-axis, but I would go counterclockwise. So that's the 360 minus 45 degrees, which would be 350 degrees. 315 degrees. The negative angle, so I already have negative 45. I would need to start at the x-axis and go all the way around 360 and then 45 degrees more. So I'm kind of like adding in a negative 360 to get negative 405. So there's my positive and my negative. Coterminal angles, so they all have the same terminal ray. We are going to learn about something new, and I'm super excited because of course it deals with pi, so I mean, it can't be much cooler than that if you've got pi going on. These are the notes that are in the Google Classroom. Some of it is in the book, so you can, I know these are a little bit tougher to copy down because of all the pictures, so if you want to, can print them. If not, you know, I can send you copies of these as well, but you just have to let me know, and you have to let me know like the week before, and then you have to go pick them up at the high school. So, but it's an option if you want. What we're going to do is look at what are called radians, and radians are, some believe, a better way to measure angles because you can use a radian to measure an angle, and you can also use a radian to measure an arc length. So the length on the outside of the circle, see where it says length? We can use radians to measure an arc length, and we can use it to measure an angle. So it's a little bit better than degrees, more versatile. The word radians comes from radius. So you know how from the center of the circle outside to the circle, that length is a radius. If we use that same length, that R length right there, and let's say we're using a string, we use a string to measure that length, and then we use that same string to measure along the outside of that circle, that length is one radius. So outside length is a radius. It's that same length as the R, it's just curved. If we continue using that same radius length and measure along the outside of the circle, mathematically, so cool, we will end up getting a little bit more than 3 of those radii. So you'd have one here, third one. And so a little bit more than 3 radii it would take to get halfway around the circle. And of course, a little bit more than 3 is gonna be the 3.14159.265.358 blah, 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 radians to get halfway around the circle, which is, yay, pi. Isn't that the coolest thing on the planet? So it takes halfway around the circle is a length of pi. And so the word radians, which is a measurement of an angle or a measurement of an arc length, is in terms of pi. And we're going to look at how that compares to degrees, and then we're just going to keep using radians because they're way cooler and more versatile. But first we got to, get used to them and what they mean. I really feel like I'm rambling. I need somebody to ask me a question or stop me. Okay, so our basis is that halfway around the circle is 180 degrees. And it's also, now we know pi radians. So if we measured it in radians, meaning how many radii, or radiuses would it take to get halfway around the circle, there would be a little bit more than 3, and that would be pi radians, because remember, pi is a number. So we're going to use that idea, and we're going to convert between degrees and radians. So down here at the bottom, we've got some examples. To go from degrees to radians, the way I remember it is, if I need to change my degrees into radians, then I need pi. So I'm going to have to multiply by pi. if I'm going the other direction from, I have radians, meaning I have pi, then I'm going to divide out the pi. Because I don't want pi anymore if I'm going from radians to degrees. I need to divide out the pi. So from radians to degrees, I don't want pi, even though I don't know why anybody would not want pi. So we're going to divide it out because we don't want pi if we're going from radians to degrees. We've got to get rid of the pi. So let's practice. So we've got on the first example, 80 degrees, and we want to change that into radians, meaning we need pi. So we have degrees, 80 degrees. We're going to multiply that by pi. But remember how halfway around the circle is pi, so is 180. So we're going to multiply it by pi and then divide out the 180, because we're getting rid of the degrees, if you think about it. So that we're dividing out the 180 to get rid of the degrees. And then now we just simplify our fraction. So we're going to multiply straight across 180 times pi over 180. I want to simplify, so I'm going to divide the top and the bottom of my fraction by 20. And so I'm going to end up with 4 pi over 9 radians. So 80 degrees is the same as 4 pi over 9 radians. Doesn't that look way better than degrees? Now I'm glad I can't hear you guys. Okay, we're going to try again. So this time we have a negative degree. No big deal. Just know it's going clockwise. We want to change, that's degrees, we want to change it into radians, so we're going to multiply by pi and divide out the degrees. And then we just do our simplifying. So we have negative 40 pi over 180. Again, this time we're going to divide by 20. That doesn't always happen, just happens in these examples. I wonder who thought of these examples. So then we're going to end up with negative 2 pi over 9 radians. Guess I like 9 on the denominator of all these examples. C. So notice on C, it's not degrees, and you know that because a couple things. You see the pi, and you see there's no degrees symbol. So we know that's in radians. We need to then change it into degrees. It's silly, but we just need that ability. So since it has pi, we want to divide out the pi and multiply in the degrees, the 180. And we multiply straight across. So 5 times 180 is 900. So I must put pi on top. And 9 times pi. Oh, there is pi on top. What am I thinking? So it's 900 pi over 9 pi, and then we're going to simplify, so the pi's are going to divide out. That's the whole purpose of dividing by pi. And then 900 divided by 99, is 100 degrees. Gosh. So pause and try B on your own. And then you've started it back up. So hopefully you started with your radians of negative pi over 5. And you multiplied by 180, because you want degrees, and you divided out the pi. So the pi's are going to divide out, and we're going to divide negative 180 by 5, and we're going to end up with negative 36 degrees. So that's how we go back and forth between degrees and radians. Moving on. The last thing we're going to look at in this section is arc length and area of a sector. And you might have done this in geometry, so this could be some review for you. If not, it'll be new and exciting. You are not going to have to memorize these formulas, but it would be nice if they made sense to you. So an arc length That's going to be the length on the outside of the circle. I'm going to highlight that. So arc length, we're talking about how long is that curved part of the circle. So to get that, you multiply your radius times your angle, but the angle has to be, this is important, the angle, it has to be in radians. Because remember how radians can be used to measure an angle and a length? So that's why we need to change our degrees into radians. So don't forget, that will be your first step, that angle degree needs to be in radians. And then the area comes from part of a circle. We're not going to go into where this formula, like how we got this formula, but it ends up being like part of a circle. So you've got your pi r squared for your area of a circle. And then the pi is going to be in the degrees because you're changing your degrees into radians. So it'll be in the angle measurement. And then the 1/2 falls in there in the calculation. So you can just trust me. It's going to be 1/2 times your radius squared times your angle in radians. Here we go. We're going to find the arc length and area of arc AB. So you've got yourself a circle. The radius is 12. Our angle is 45 degrees. The first thing we want to do before we find the length or the area is to change our 45 degrees into radians. So to do that, I'm going to start with my 45 degrees. I want to multiply by pi because I want radians, and I'm going to divide out the degrees, which is 180. And we're going to simplify that. So multiply 45 times pi divided by 180, do your simplifying, and we're going to end it with pi over 4 radians. So that's how many degrees, or that's how much our angle is. Not degrees, it's in radians. And then we're going to use that then to find our arc length and the area of our circle. So length, we're going to just take our radians and multiply it by the radius, which is 12, and then we simplify. So pi times 12 divided by 4 is 3 pi, and we don't know what our units are, so I'm going to just say units. And we're going to go with the area of our sector. Just make sure you remember the area is like how much of the circle. How much, it's a part of the area of the circle. The area of the sector is part of the area of the circle. So the area is going to be 1/2 times our radius squared, so 12 squared, times our angle. So how much that's the part of the circle, and that's in radians, pi over 4. And we simplify. So we're going to have 144 pi divided by 8, because 2 times 4 is 8. Simplify that down. 144 divided by 8, we're going to get 18 pi units squared, because this is the area. You're going to have to be careful on big ideas. Make sure you read the directions. If it asks for a rounded, then they're going to want you to multiply 18 times pi and get a decimal. So just make sure you read the directions. These don't have any directions, so I'm going to leave them nice in radian form with the pi. It's easier that way. Okay, B. So go ahead and pause this video, try B, and then I'm going to go through the process so you can check it. So the first thing I'm going to do is start with my 150 degrees and multiply it by pi and divide by 180 to get myself some radians. I'm going to simplify the fraction and get 5 pi over 6 radians. So that's the measure of my angle in radians, and then I'm going to use that to find the length of the arc. I'm going to start by taking the radius and multiplying it by the angle measure in radians. And then I'm going to simplify to get 25 pi over 6, and this time it's inches. Again, on your homework, make sure you read the directions. It might want you to write your answer in decimal form. Then we're going to go with the area. So to find the area, I'm going to start with half times my radius squared times my angle in terms of radians. And then I'm going to simplify. Well, multiply first. So 100 times 5 pi, 100, yeah. And then 2 times 6. So 500 pi over 12. Simplify that down to 125 pi over 6. And this is the area, so it's inches squared. Make sure you read the directions on your homework. See if they want it in terms of decimals. The last example, we had a real life softball field and we want to know what the area of the softball field is. So softball field is not a whole circle, right? It's part of a circle. And it is a right angle at the center. So this is a 90 degrees. And they're telling us that the dimensions are 180 feet on each side. There's another example in your book that gives you one with 200 feet on each side. So you can use that, try that example as well. So I'm going to first start by taking my 90-degree angle, and I need to change that into radians. So I'm going to multiply by pi, divide by 180, which would be pi over 2. Radians. So that's the angle in terms of radians. I now get to find, oh, I should have read the directions. Find the length of the outside fence. So this guy out here. So that length I'm going to find, and then I also need to find the area of the field. So I'll start with the fence length, which is going to use my radius, 180, times my angle in radians, which is pi over 2. And usually fences are not measured in radians. They're usually measured in decimally feet. So I'm going to type this in my calculator. 180 times pi divided by 2. And then I'm going to round that to the nearest foot. Just to kind of be realistic, you're not going to want to know the decimally length of a fence. So we're going to round it to the nearest foot. Then looking at for the area of our field. So this time we're going to take our radius squared. We're going to multiply it by our radians, and I also need to take half of that. So half of 180 squared times pi over 2. Just type it all in your calculator, and we're going to get about 25,447, if we round up, feet, and that's squared area. Yay, we did it. So those are our 2 days of lessons for the week, video lessons for the week. Make sure that you are practicing on these big idea problems, and then upload a picture to the Google Classroom so I can see it and give you credit. Make sure you're checking on bigideasmath.com. So the problems are page 474, 5 through 17 odd, 18, 22 through 30 all. No problem. You guys can get that done. That's due by Friday of this week. So try not, if you're already behind, try to get caught up on all that stuff. And if you have any questions, remember Google Meets. It's on the calendar, and I'll put it on the feed, also the Google Classroom feed. This, you guys, please let me know if you have any questions, and take care of yourselves. Talk to you later.